Good day, everyone. My name is Manjul Hassan. I'm a PhD candidate at the University of Alberta. Today, I'll talk about OHS requirement in tunneling construction, and I'll introduce you to our TunnelingSafe training website. Welcome to my presentation. Tunneling technology is evolving and improving. The technique has become more efficient over the years, and therefore cutting the production time and the cost. This is a clip from a newspaper a few years back. A 44-year-old city worker died inside an underground sewage tunnel under construction in southwest Edmonton. Such incident happens. What is the consequence of this? The entire production process halts for an indefinite amount of time and makes the efficiency improvement meaningless. Therefore, we need to be very delicate about managing occupational health and safety in construction sites. Here, I'm presenting two definitions. What is occupational health and safety management? Basically, it is a management system to minimize the incidence of injuries and illness at the workplace. What is the aim of this OHS management system? The aim is to ensure that the productive work is designed and performed with workers' health and safety in mind. In Alberta, there are 4 legal documents that we have to follow regarding OHS. First one is Occupational Health and Safety Act. Second one, Occupational Health and Safety Regulation. Third one, Occupational Health and Safety Code. Fourth one, Workers' Compensation Act. For tunnel construction, information is so much fragmented. That means information lies within the documents that I listed above. I would like to make a point over here. In Alberta OHS is the minimum threshold that should be followed in any construction site. It includes all the 4 documents that I mentioned in this slide. Now, question for the audience. Which country has the best workplace safety practice? Here, I plotted fatal injuries per 100,000 workers against time. And if you look closely, you'll see that United Kingdom has the least amount of fatal workplace-related injuries. What is the conclusion that we can draw from here? We can say United Kingdom has the better safety management system in place than others. Where does Canada stand? I plotted the same graph as the earlier one. The cumulative total injury for Canada per year is more than 10, and it is not following a declining trend. So we have an opportunity over here to improve our workplace safety culture. If we do a literature search, we can find that United Kingdom has one code specific to tunnel construction. The code is comprehensive, addressing technology and equipment and new techniques in tunneling. So that what we did was we tried to put together all the good information presented in that code, and that code is BS6164, so that we could understand the best industry practices in other countries. A similar AOHS code is also presented to make a contrast, so that we understand what is the similarities and what is the differences. What are the differences? Again, I'd like to remind you, in Alberta OHS is the minimum threshold to be followed in any construction site. So, what is TunnelingSafe? It is a training program which is developed as a website containing of training materials, and evaluation tools that we can provide to an organization or any organization actually in Alberta or other municipalities. So they can be knowledgeable about occupational health and safety practices in tunnel construction. The TunnelingSafe program incorporates and adapts the British experiences and systems so to align with the Alberta OHS legislation, present practices, and industry needs. The training program focuses on sharing knowledge on the best safe work practices in a tunnel under construction or also in service. What are the training goals? The training goals are to serve as a training tool that provides information on safety and occupational health in tunneling industry based on BS 6164 and Alberta OHS code. To provide industry leaders an insight on how the Alberta OHS code system compares to the BS 6164 and have a better understanding on the similarities and differences. The aim is to provide additional knowledge to improve safety planning in tunnel construction and disseminate good practices. Over here, I'm showing a screenshot of the TunnelingSafe website. If you look at the left corner, you'll see there are 4 chapters of this whole training program. And now, if you get into in each specific chapter, you'll see Alberta OHS code is also presented over here with relevant information in relevant chapter. Few disclaimers before we proceed. These materials contained in the Alberta TunnelingSafe training program are provided for information purpose only. Users, including trainee and trainers, are expected to be aware of and complying with applicable legislative requirements at all the time. Where the best practices differ from the Alberta OHS legislation, the Alberta OHS legislation shall be minimum threshold required to be met. Now, let's talk about TunnelingSafe program applications. How we should integrate the safety with construction plan. First, we should see the construction plan. That means we decide what we have to do. Then, how to do. See the engineering details. Next, we should see what would be the best safe work procedure. That means exploring the OHS legislations. Then we'll create a safe construction knowledge base that will help us to create the crew-specific safe work plan. That is what we'll hand over to crews, and that is what we'll inspect for. Now, I'm going to present you with a case study on tunnel project. The tunnel was constructed using NATM technology. The NATM stands for New Australian Tunneling Method. The construction process involves 4 distinct stages. This study tried to differentiate the safety cost from the actual construction cost. The study was done by Nguyen as part of his image project. Here, some screenshots of the construction steps. First, ventilation and lighting are installed in the construction site. Now the canopy tube is installed. Now we see the lattice girder installation. Now we see a screenshot of dirt removal process. This is a picture of a spraying initial lining layer. This is one shot of excavation of initial dirt. In this picture, we see the waterproofing membrane is installed. Over here, we're seeing the reinforcement installation. Here we see the cast-in-place inverse sections are installed already inside the tunnel. Here, crew are setting up formwork for arc bore. This is the inside view of the tunnel after final lining is completed. Now, let's get deeper. Our first stage was the work preparation. To prevent the incidents like falling from a height, here we presented the best practice beside the AOHS code and used it for planning safety on construction site. So basically what we did, we compared the BS code and AHS code side by side, and one is complementing each other. For example, for falling from heights, the chapter 1 of the BS code is, or the training program or the website is referring us to have safe measures preventing all the risk that is associated with falling from height. A fixed barrier near the fence or the excavation can reduce the risk of falling from height. Besides, Part 32, Section 444 of the Alberta OHS Code is referring us to do something similar. If there is a danger of a worker or equipment falling into an excavation, an employer must ensure that workers are made aware of the excavation through flagging, marking, safeguarding, or other appropriate and effective means. And Part 32, Section 6464, one has some message too regarding this as well. Here is another example. Installing ventilation. Our BS code specifically talks about ventilation requirement. Next one, another example is about lighting requirement. Both BS and AOHS have comprehensive guidelines about lighting. Here are some of the guidelines. Now, if you look at the work breakdown structure of the work preparation stage, we see that about 8 activities need to be completed during this stage. If we pay attention, we'll see all 5 are safety-related activities among the 8. That means that is a major part of the activities that have to be carried out or carried through during this stage. In the next stage, we try to quantify the safety cost. That means how many dollars we had to spend to ensure the safety of the workers. First, look at the support crew. We'll need 4 persons for the job in this stage, dedicated to ensuring that the workplace safety is in place. The total cost is $155 per hour. Next, if you look at the actual crew, it will cost only $165 per hour. That includes both equipment and labor. For work preparation phase, it will take 16 hours total to complete activities 1.1 to 1.5, and another 2 days to get through activities 1.6 to 1.8. The total duration of this phase is 32 hours, that means 4 days. For the first 2 days, safety crew is utilized. Therefore, the safety cost is around $2,480. For the next 2 days, drilling crew is utilized. We assume that for every 8-hour shift, 30 minutes are spent for safety purpose, such as daily toolbox meeting, review of field level hazard assessment. Therefore, about 6.25% of the cost will be transferred from direct labor cost to safety cost. And if we do the calculation, we find the total labor cost over here is $1,725. The equipment cost, on the other hand, is $800. However, the safety cost is $115. Beside the regular crew, we should also account for the management cost. Management personnel needs to visit the work site. Therefore, we'll need safety orientations and also the PPE. And it will cost something. Over here, we are seeing the safety related cost due to a management visit is $120. Apart from this, we have to spend some money on safety gadgets and gear. Here is a simple list. We have to buy few air or gas monitor. We have to buy few confined space equipment, some other personal protective equipments, walkie-talkie, etc. If we combine all this cost together, definitely we can come up with a total sum of the cost that is related to safety. And actually, we did that. We did such a calculation for all construction stages. That means all 4 stages. This slide presents the cost comparison among different construction stages. We see the maximum amount of money was spent during the preparation stage. And that makes sense because we had to buy equipment, we had to install proper safety gear, and provide training to the personnel. During the following stages, safety costs are involved only for the regular inspections, supervision, briefing, and safety meetings. Therefore, comparing with the labor cost or equipment cost or construction actual cost, it is much less. Please don't be confused because the costs presented here are just for one cycle. There can be 10 to 1,000 cycles depending on the length of the tunnel. So in conclusion, we can say, while planning a tunnel construction job, we must have to be delicate in planning safety as well for the well-being of the workers. And of course, we have to account that cost in preparing budget and preparing plan. That concludes my presentation. Thanks for your attention. If you have any questions, you can actually ask or you can directly email me. My email address is mdmanjur@ualberta.ca. Thanks for joining.